B to D, and I told you that this is 10, so don't write that down. I'm making that up. Wouldn't B to C also have to be 10 because it's a different radius? It's part of the triangle, but it's still the radius of our circle. Well, if that's 10, wouldn't B to A also have to be 10? Aren't all three of those the radius of our circle? Okay. So the key with this is understanding that whatever this length is right here, wouldn't this have the same identical length? So instead of using numbers, because we don't know what they are, we don't want to make them up, the way we show that we know these are in fact congruent, whatever they are, is with these tick marks. So when I ask you to tell me what type of triangle this is, the type of triangle that has two congruent sides is an isosceles triangle. All right, so that's what we're getting at with this one. That is an isosceles triangle. And then in terms of how do we know that, we're going to put two of the sides are the radius of the circle. And every radius in a circle is going to be the same length. So that's how we know those are equal. That's how we know that's an isosceles triangle. Okay. Okay, that then there's another thing that deals with this isosceles triangle. It says, how are angle BAC, so angle BAC, so this angle right here, and angle BCA related to each other? So when we dealt with all these isosceles triangles, remember how we said whatever two sides are congruent? Remember how we also said then the angles opposite of them are also congruent? So what this is getting at is just refreshing our memory a little bit about how angle BAC must be congruent to angle BCA. All right, old isosceles triangle stuff. And then we would just say because they are opposite of the congruent sides. All right, so that's basic isosceles triangle stuff. We're just getting it from a circle and understanding that the radii are the same. Okay. All right, number 3. Angle DBC is an exterior angle of ABC. So hopefully we look at this. You see I have highlighted in blue, yellow the interior of the triangle. DBC is this exterior angle. Okay, it's outside of that triangle. Exterior angle. At the very beginning of this semester, back in January, we talked about these exterior angles. That's when we talked about how these all add up to be 180, all of that stuff. So that is an exterior angle. It says, how can we find the measure of angle DBC? So DBC, if we don't know this angle right here. All right. Well, what this gets at, so let me draw in as a quick little refresher. When we were to have a triangle that looks like this, and then we would have an exterior angle. Let's see if this refreshes our memory a little bit. Remember how we would get this angle if this angle was 70 and this angle was 60? Remember how this exterior angle is the sum of the two angles that are opposite of it? So we would then know that this angle is 130 degrees. That's what we're looking at here. That this blue angle would have to be the sum of this angle here and this angle here. All right, so we're going to write that with notations that angle DBC, so this blue angle, DBC, so write that one first, would have to be equivalent to the sum. So we're going to add the two angles. We call them the remote interior angles. It's the two angles that I have with those little arcs. So the first one is BAC. And then the second one is over here. That is B to C to A. Those are our remote interior angles. All right, that's how we could find it if we knew those. Okay. All right, so now in number 3, pick whatever you want. Try to be realistic about what those angles look like. But what you're going to do, and you can be creative, come up with your own, you're going to give the BAC and BC a specific measurement. So make it up, whatever pops into your head, make it reasonable, though, make sure it works, and then use those angles to find this. So what I mean by that is whatever you think this angle might be. So don't say that this is a 180 degree angle, because isn't that an acute angle? It's small. So come up with a reasonable guess for what this angle would be here. All right. And we could have a bunch of different options. All right. And Lily, what did you put down?
37.
Okay, so she said if that's a 37 degree angle, then isn't this also a 37 degree angle? If we did that, so if these are now both 37 degrees, and again, you could have something different, then wouldn't we now know that this angle, so all you're gonna do is take whatever angle you assign, we know those are congruent, so you're gonna give both of those angles that degree measurement, and then I would get 74 degrees for Lily's problem. All right, and so you're basically just gonna double that. It's the sum of those two remote interior angles, okay? So now, kind of understand what that means. Go to your number 4 and answer. I think this is, yeah, the last of 2. So let's say angle DBC was 80. So if this was an 80 degree angle, write down what those other 2 angles would have had to have been. All right. If our blue one was 80, so now let me create a little space in here, get rid of these. What did these 2 individual angles now need to be? Ben? Good. Those would have to be 40 degree angles so that when we added them together, you're going to get that 80. Okay. Same exact idea, just worded a little bit differently now. Now find that angle BAC is 30. So find that angle, give it a value of 30, and then tell me what angle DBC would have to be. All right, so now in this one, this angle is a 30, and we're just asking you what this angle here would now need to be. All right, Ella, what's that going to be?
60.
Good. This would have to be 60 degrees. All right, so what I want to have you add, one last thing. So write down a number 6 down here to kind of understand what this is, because this now gets into what we're really going to dive into tomorrow. So write this in your number 6 that you added. I'm going to write it right here so you understand what I'm referring to. Is that this angle right here, some definitions that we defined the other day, that is what we would call an inscribed angles, or an inscribed angle, right? That's where the vertex lies on the circle, is always going to be 1/2 of that central angle that it also creates. And the central angle is the angle that's formed at the center of the circle. So wasn't this central angle always 1/2 of the inscribed angle? Okay. In many ways, that's what we dive into a lot tomorrow. We'll obviously add some layers to this, but that's what we kind of want to get out of it. And obviously, we're going to get all that done today. So that's why we just kind of went over this guy today. And then tomorrow, we'll get into that more. All right. So that's all I wanted to kind of get through today. So no homework. All right. We'll do it tomorrow. And then we'll see if we have a little quiz or something on Friday. Okay. Yeah.